Shall I start? Yeah. So, hello everyone. I am Archana Arya, a PhD student in Triple IT Delhi. So, today I am here to give you an overview of Python 3, focusing on topics like NumPy, SciPy, and Matplotlib. Okay, so for this, we are referring Introduction to Scientific Programming with Python by Sundance. And you can, so there is one resource that you can also refer, which is a primer on scientific programming with Python by Hans Peter. Okay, so let's start with a very basic example. Suppose you want to run hello world to the screen. So for that you need to run this command and it will print hello world on the screen. Okay, so there are some ways how you do this. So first is that type and run it in a Jupyter notebook like I'm doing. And second way is to write and run the hello world. Uh, Open an editor like Atom, gedit, or Emacs. Type the given line and save the live file with a suitable file name, for instance, hello.py. And then you have to open a terminal. And if you are opening a terminal, then there you need to type Python hello.py. And if you are opening a IPython window, there you need to type run hello.py. So this will give your output hello world to the screen right after the command. Okay, now since this school is on shape modeling, so we will focus on Python with the scientific computing rather than the general programming of Python. Okay, so here is a very simple compound interest formula that we usually read in our school time. So suppose you need to calculate this value for p for these values. So for that you have to put that value in the formula and just run it, and then it will evaluate the value. Okay, so note that we are not using quotation marks here like we did above in hello world. This is because we need to evaluate this rather than printing. So what happen if we put quotation marks? So it will print the statement exactly it is. Okay, so next you can also assign variables to values. So this will make your program more readable, and it is also convenient. So you can, if you want to change the value of a single variable, so you can easily do that like that. Here you want to 4.0. So this is possible here. Okay, so obviously this will also give the same output. Yeah, the choice of variable is completely up to your choice. So here are some more variables, and obviously it will also give the same output. But choosing good variable is a little bit necessary because of readability. So your variables should be descriptive, but it should be concise as well. Okay, so these three statements above are known as assignment statements. Here is one more example for assignment. So
sorry, Archana, maybe we can zoom it a little bit.
Okay.
Okay, hopefully.
Okay. So yeah, so these are assignment statements. Here is one more for assignment statements. So we are assigning here 0.6 to t. After that, we are updating the value of t by 0.1. So this is the way to doing that. And it will update the value to 0.7. Okay, so note that for equality, we are using a single equality sign for assignment, sorry. And if we need to compare two values, so for that, we need to use double equality signs. Okay, so yeah, comment is a very useful in Python. So to explaining our thoughts in programs. So we can do this by using hash. So this will make the command to be a comment, and these comments are completely ignored by Python. So you can take your variable small and explain it by using comments. Okay, so yeah, variables has types as well. Okay, here we are assigning hello world to hello, and we can check the type of variables using the built-in function type. So it will so if you are checking the types of this, so this will print the type of every variable. Since so our hello is a string variable, r is 5.0, so it is a float variable. Similarly, principal and n are integer values, so it will print int for that. Okay, so how can we how the standard arithmetic operation work on these string variables. So if we add two string variables, then it printed twice. And if we multiply it by 5, so it will print it 5 times. Okay, so this is a good one example to compare these two things. So you note that x1 is a 2, which is an integer, and next x2 is a 2, which is a string variable. Okay, so what happen if you add these? If you are adding x1, then it will evaluate its value, and if you are adding x2, then it will printing it twice because it's a string variable. Okay, so yeah, you can also convert that float variable, oh sorry, string variable to the float number by using built-in function float, like in this example. So here it converted x2 into a float number, and after that it is evaluating x2 plus x2 equals to 4. But the necessity is that your string variable should be a number. It can't be a string. So what happen if you float hello? So it will create an error because it is a string variable. Okay, next, yeah, if you want, if you print this, so there is no problem in this. It will giving you a correct values, but you can make your output more readable. So suppose if you want to print your output like this way, so it is completely readable. What are these values? So for that, you can use f string. So this f denotes that this is a f string, and after that, what you need to print, you can put it in quotation marks, and the variable you want to change, it should be in bristles. So this will print the required result. Okay, so next is that you can also evaluate expressions in f string. So it will evaluate 2 plus 2 equals to 4 and print it as well. Okay, so you can also control decimal places you need in Python. So suppose here t is this value, and for that you can there is a you can use f string, and the this term is known as format specifier, we are using here. Okay, so if you run first command, it will print t as it is. Second, it will print t up to point 2, and in third it will print t up to point matlab, up to 2 floats. Okay, so yeah, if you can also manage how much space do you need to print a single number. So here it is taking space of 8 digits, and you can do the same job with integers as well. There is another format specifier known as generic format specifier, and it is denoted by G. So it will print the number in very compact form, like it is doing here. Okay, so next is modules. Okay, so unlike standard arithmetic operations, these advanced mathematical operations like sin x, cos x, and ln x are not available directly in Python. So for that, you need to import it from a module. So these functions all are available in math module. Okay, so suppose you want to use square root functions in math module. So for that, you can import math in 3 ways. So this is the one you can import the whole math and use square root like this, math dot square root, and you can import only square root from maths. At that time, you don't need to put math dot in front of this. And you from math import star will import everything from maths. So here you can also write square root or any function you can use directly from math module. Okay, so suppose next you want to evaluate this value. Okay, in this we need three things. First is square root, second is pi, third is exponential. So we will import all of these three to from maths, and put it in the formula, and it will evaluates the value for these values of m, s, and x. And okay, so you can also find the information about any Python module. So for that, you first need to import.
All right, sorry.
Hello. Okay. Yeah, I'm telling that we can import, we can find information of any Python module. Suppose we want to import the information of math module. So for that, first we need to import math.
Actually, you could turn it on also.
Okay, so from here.
Think it's
Okay, so yeah, sorry for disturbance. Yeah, so I am saying that we can also find information about Python modules as well. So for that, we will use built-in function dir. So suppose we want to import, so suppose we want the information of a math module. So for that, first we need to import it, and after that we have to put math in the built-in function dir. So it will print the whole directory of maths. So these are the function available in math module. So for more reference, you can refer the Python library reference, which contains information about all the standard modules that are distributed in Python. Okay, so now we will discuss some errors we are really worth to know about. Okay, so first is round of errors. Okay, so look at these two numbers. Uh, they are seemingly to be equal 1, but they are not if you compute these values. So it will print, first one is equals to 0.999 and so on. And second one comes equal 1. Okay, and if you compare these values with 1, so first becomes false, which is obvious, and second is true. So it's better to compare the values using tolerance value to get rid of errors. So if you do this, so it will print true. Okay, so choice of tolerance variable is completely up to you, but it can't be larger than typical machine precision, whose value is 10 to the power minus 16. Okay, so next, here are some keywords which are reserved in Python and can't be used as variables. So here is the list of all these variables. Okay, so coming next to the most of the important topics, which is loops and list, and it is widely used in Python. So to automate repetitive and tedious operation, we use loops. So here we will discuss two types of loop. The first one is while loop and second one is for loop. Okay, suppose you want to print this value, but for different values of n. So like you want to print these two columns. So what will you do? Okay, so if you want to print this for a single value of n, obviously it will print that easily. And intuitively, what you do first, you will assign every value to that n and will print that. But it is really repetitive and too boring. So to get rid of this, you can use while loop. This is a journal format for the while loop. Okay, so here is the example for above one, how we will apply while loop on it. So it will print exactly the thing we need. So what we need to do, first we need to assign the values, and the initial value of n we need to assign from where we need our loop starts, and run it up to value 10. Okay, so after that we will put the statements we need to compute or print. And the necessary thing is we need to update the value of n, otherwise it will remains 0 all the time and the infinite loop runs over. So what does this loop do? It will take value n equals to 0. So if this condition holds true, it will insert the loop, and so it will insert the loop, and after that it will calculate these two statements, and after that it will update the value up to 1, and it will run up to a value of n equals to 10. For n equals to 10, this condition also holds true. It will run these statements, and here it get updated to n equals to 11. Okay, so when n equals to 11 is tested, here we get false statement, and the loop is quitted then. So here the process what we are doing that in above loop. Okay, so yeah, this expression is known as Boolean expression. And here are some more examples of Boolean expressions. So say t equals to 40, t is not equal to 40, t is greater than equal to 40, and so on. Okay, so next, here are some example of Boolean expressions we are comparing. So say c is 41. So yeah, c is not equals to 40, so it will print true. and c is less than 40, so it is false, and c equals to 41, it will print true. Okay, so we can also combine multiple statements using in while loop using and or condition. So for that, the result totally depends on your conditions are true or false. So as in, if your both conditions are true, so with and or as well, it will return true statement, and same is for false. And but if your one statement is true and another one is false, then with and it will return false statement, and with or it will return true statement. So there is one more expression, say not, so it will convert true to false and false to true. Okay, so here are some examples for Boolean expressions. So say we are assigning x equals to 0 and y equals to 1.2. So first one is x is greater than equal to 0, so it's true, but y is less than 1, it is false. So with and it print false, and but with or it is printing true. And so similarly, so you can say last one. So x is greater than 0 false, or y is greater than 0 true. So this will true statement, but with not it will give output as false. Okay, so next is lists. Okay, so suppose you want to store n values, say from 0 to 10. So what will you do? So first, the intuitive way from the thing that you have learned now. First, you define and assign it to every variable, but it's really repetitive and boring. So there is one more flexible way, and it is known as list. Okay, so this square brackets indicates that n is a list. And you can also insert string variables in list, float variables, and integers, anything. Okay, now if you want to pick a particular index element of a list, so for that, what you will do? So for that, first you need to write the name of the list, and in square bracket, the index you want to need, you want to print or so on. And this len function compute the length of the list. So if you run this, you will get these values: 0, 4 at 0, 6 at 1, and minus 3.5 at 2. And the length of is 3. Okay, so here are some more functions that you can apply on list. So suppose we have this list. It contains elements from 0 to 8. Now you can also append, add a new element in the list using append function. So this will create your list up to 9. You can also insert elements in list like using this. Okay, so this will print list up to 11. Next, you can check whether variable is lying in that list or not. So suppose you are checking 9, so is 9 in n, so it will print true because it is in n, in updated list. It is in updated list. Okay, and if you print it is 12 in n, so it prints false because 12 is not in n, it is up to 11. Okay, you can also delete a particular entry from the list using del function. So here it is deleting 0th entry of the list. You can notice it here. Okay. So yeah, next is if you are assigning a value of list to a new variable and making changes in new one, then it will also reflect to the old one because it is making changes in original one. So if you want to make a change in a list but don't want to reflect it over a new list, so for that you need a copy function. You first make the copy of that list and make the further changes you want to do. Okay, so next is iterating over a list using for loop. So we will use for loop using a so to iterate over a list. So this is a general format of for loop, and here is the example we are using above. So suppose we want to compute a value of amount for n running from 0 to 10. So for that we will use for n in years, and it will pick value of n from years and evaluate the value and print it in the same way that we will so we did for while loop. Also, okay, so this program it is just using f string and printing it in more nicely aligned columns. Okay, so you can also translate for loop to a while loop. So suppose we have this for loop. Okay, So suppose we have this for loop and we need to convert it into the while loop. So this is the format for that. Okay, so next you can also use range function to loop over indices. So suppose you need to compute the value of amount function again for value of n from 0 to 10. So you can use range for it instead of using list. So you can range of range n starting from 0 and up to n. So note that this n plus 1 is not included in range function. It is will run up to the value of n. So this is the general format for range function. It accepts 3 variables. Okay, so the default value of start is 0 and the default value of increment is 1. So if you will inserting only one variable, so it will treat it as a stop value. And if you are taking two variables in the parenthesis, it will treat it as a start value and stop value. Okay, so we can also fill a list using the for loop. Suppose we have, for that we start with an empty list. Suppose we have these empty list amounts. So this is a way of defining an empty list. Then we will start looping over the indexes and will insert this value and append do the job for it. Okay, so this will create the whole list. Okay, so next is an example of sum. So we can also compute this sum for different values of n using this code. Next is we can also change the elements in a list. So suppose we have this list -1, 1, 10, and we want to update its entry by 2. So this is the most intuitive way we will start doing, but this is not correct. It will not update the value in this. So for updating value of elements, you need to loop over its index, like in this program, and it will update the values of our list. So here is the updated one. And list next is list comprehensions. So you can define list in a more precise form. So this is the format. Okay. Okay. So after that, okay. So here is the list comprehension. It is the same for the loop for element in some list. New list is equals to some of the expression we need to compute. And yeah, so if anyone has any doubt or query, you can ask. Okay. So we can continue now. So this is the this program is just filling two empty lists together, a high and a low, like the way we did in this program for amounts. Okay. So yeah. So it will update a low and a high. Okay, so if we want to loop over two lists consecutively, so what we will do, there is a one way using range function, and it's the process we can run over every index and print the corresponding entries. But we can also use zip function, which is available in Python. We can zip the two lists together, and consecutively it will pick values from the list and print it. So it will give the same output as above. Okay, so you can zip three lists as well. Okay, so the precaution is that if you are when you are zipping the list, the length of list must be same, and if they are of different lengths, then they will stop for the shorter one. Next is the nested lists. Okay, so we can also create a list of list in Python. So here is an example. So a low is a list, a high is also a list, and we are inserting it again in a list. So amount is a nested list. Okay, so if we print zeroth index of amounts, then it will print the whole list a low, and similarly amounts one print the whole list a high. Now if we want to access a particular element from that nested list, so for that we need to first write that index, which one we need from this one or from this one, and after that that entry of that list. Okay, so this will print the third element in a high because one indicates a high. Okay, so here is general formats for nested lists. Okay, here is one more example of for nested list. So L is a nested list which contains two lists. So row run over the list of L, and then column run over entries in row, and will print it one by one, like here it is printing. Okay, so we can also extract a particular or access a particular part of a list. So like in first one, so A is this list, and this function will print the list from index 2 up to the end of the list. And next one will print it starting from 1, but it will print up to the second index. Similarly, like in range function, it also not includes the last index. And this will print as above uh, up to second entry, starting from the beginning. And here -1 indicates the last element, so it will print from starting from 1 and print up to next last element of the list. Okay, so it will print the whole list here. Okay, so yeah, next thing is tuples. Oh, it is defined similarly in the way we define it in maths, but here is a choice. We can skip parentheses by when we define a tuple in Python. So if we need to add a particular value to Python, we can do it like in this way. Instead of using append function will not work for it. And we can also, like in list, write a particular element using its index, and similarly the part of tuple. And we can also check whether an element lies in that list or not. So is 6 in TI, it is in, so it will print true. Okay, so yeah, now tuples are immutable, so they can't be changed. So if you're trying to change its entry, it will give an error. You can also not use append function with it. It again gives an error, and you can't delete its entry as well. It will also give an error. Okay, so next thing is functions and branching. Okay, so we can also define functions in Python. So we have some directly available functions, sinx, logx, length, appended that we discussed before. So like this function, we can also define our own functions. Suppose we want to write this formula this time for as a function over n. So this is the way we can do for this. Okay, so okay, so this def indicates that this is a function in Python. Next is okay. So when we when we need the function, we need to call this. That process is called calling, and this is done by these two ways. So you can directly put the value of variable in that, or you can use a keyword for that and assign the value before for that. Okay, so it will print the it will, so when you call it, the values goes in this function, and the value in parentheses and is replaced by that, and it will return this value by evaluating it. Okay, so next is function arguments and local variables. So these variables which are in parentheses, so these are the function arguments, and we can assign values it in two ways. So we can do it this way. So these are known as positional arguments, and this that we specify with name, these are known as keyword arguments. So this is what explained in this topic. Okay, so next is local variables and global variables. So the variables that you define within the function are known as local variables. Like in this function, p and r are local variables, and the function that are defined outside the that the variables that are defined outside the function are known as global variables, like year one. Okay, so here are some examples. Okay, so here p and r are global variables. So we can also define global variable and local variables with the same way like we are doing in this program. So here r is a global variable as well as it is local variable, but the function uses the value of local variable unless it is not available within the function. At that time it will take the value of global variable. Okay, so if you change the value of local variable, it will not if reflect over the global variable. If you print outside the function value of global variable, it will not be updated. It is as it is 5.0. Okay, but you can change the value of global variable within the function as well by using keyword global. So it will update the value of global variable. So if you see that it now our R becomes 4.0. Okay, so any query up to here? Okay. So you can so there is one more way for updating value global variables. So you can use local variables within the function, but make it return while returning the function. And after that, you can assign it to global variable. So it will also change the value of global variable. So here R is 4.0. Okay, so you can also, like in this function, you can also return the multiple values, but it is returned in the form of a tuple. Okay, so let's see for this example. So it is returning a tuple, and yeah, it's defining its type as well. And you can also unpack these values, but the number of variables you use should be equal to the length of that tuple. Okay, so here are some more more programs to define functions. You can go over this while we upload it on Google Drive. Okay, yeah, so a function does not need a return statement. Okay, so you can also use so you can also just print the value from in a function. You need not to return something from the function. But if you assign some value to some variable to that function, it will return the term none, like in here. So here 3.4 is printing because of that function, and here if you're printing value of return value, so it will returning none. Okay, so here you can also use f string within your function to print to your output more nicely. Next is default arguments and document strings. Okay, so default arguments are these kind of arguments. They are often called keyword arguments, and we don't need to give their value to the function. So like in this example, so suppose this is a function, and here are two default arguments are defined, keyword argument 1 and 2. Okay, so here you are not giving value of keyword argument 1 and 2, but if you print this function, it will take these values from here, from its definition. And you can also change the value of keyword argument. Like, so if you are changing it at third position, it will change the value of keyword argument 1. And similarly, it will change the value of both 1 and 2. Okay, suppose if you want to change the value of keyword argument 2, but not the value of keyword argument 1, for that you can do it in this way. You can update keyword argument 2, and first one is not updated, second one is updated, and here you are updating both. Okay, so you can also use default arguments while defining a function, like here in this example we are doing. Okay, so yeah, next is documentation of Python function. So what is it? So it will tells us what our function is doing basically. So for that you need to write what you want to say about your function in this three triple quotes, and after that you need to run this command. And if you run this, it will give you what you written above about your function. Okay, so yeah, any doubt? Okay, so next is if test. So suppose you want to define this function. So these are defined on the basis of these two conditions. For that we need if loop. Okay, so first we need to import sine and pi from math first, then that is we are doing here. After that we are defining fx, like that if our x value of x is between 0 to pi, then it will return sine x, and else it will return 0. Okay, so next is so this is the okay. So there is maybe case when we don't need else block. So we only need to we only want to test a particular condition. For that we can skip the else block. Like, so this is a general format for that, and this is a general format for if and else block. Okay, so there may be case we need to test multiple conditions. So for that we will use the command if. It indicates else if. So this is the general format for that. And here is an example. So suppose you need to define this function and it will contain so many conditions. So you do that job in this way. So you need so you define nx. If x is less than 0, then it will return 0. Else, if x is in between 0 to 1, it will return x. And then if x is in between 1 and 2, then it will return 2 minus x. And if x is greater than equal to 2, it will return 0. Okay. Okay, so you can also use a shorter code for if test, and these are known as inline if tests. And so suppose you want to run this code, so you can convert this in a single line. So this is the same for the above code, like we are doing here for this example. So here, okay, so that we printed in at first. So this is so for this example, this is a inline if test. Okay. Okay, so next is yeah, yes, you can use functions as arguments to functions also, like we are doing in this example. Okay, and yeah, next is a lambda function. So if it will define the function in a more compact inline function. So if you need to define this function in a very precise form, so you can do it in this way. And this is the general format for lambda function. So it is equivalent to defining this function. And you can also use lambda function directly. Okay, so next is user input. In this section, we will show how we can extend our programs with simple yet powerful systems for user input. Okay, so we can also obtain our input using questions and answers. So like in this example, so it will ask you about the value, and if you enter some value, it will print that. Okay, so you can use this thing for inputting value in a variable, and I use that variable after later for computing some value, like in this example. First it will ask for you value, and if you enter it, then it will evaluate. So this is our h and this is our p. Okay, so yeah, here is one more example for that. Okay, so next thing, if you want to read data from some file, so this is a general format for that. You can use built-in function open. First, you have to give the file name from your want to read the data, and then R indicates reading. So, but for open function, R is a default argument. If you do not insert any argument and just give the file name, then it will also read the data. So this is example for that. And you can also write the data to files, but for that you must need to use the W for writing. Otherwise, it will read the data. So suppose this is a given data and it is writing in that, and it will return this. Okay, so next is a very important topic in Python, which is arrays. Okay, so in this section, we learn first to visualize mathematical functions and result of mathematical calculations. And after that, we will learn to plot the function using Matplotlib package. And then we will introduce the package NumPy, which is useful for storing arrays of data for efficient computations. So before starting that, if there is any question, any query up to here. Okay, so Matplotlib will plot a curve using straight lines between points along the curve. So for that, we need to assign them either list or arrays, that we will discuss later. Okay, so here we are defining arrays. It is just a generalization of vector. But unlike list, they are less flexible. We can't add entries in it. It has fixed length. So here are some example of arrays. Okay, so next is it's defining that I discussed earlier to store values of x and y for a curve to plot using list and arrays. Okay, so here we are defining this function which we use later. Okay, so here how we'll assign the value of a function to a variable which we need to plot. So okay, so what does this linspace function do? So it is available in NumPy, and it will return the value starting from 0 up the n equidistance value starting from 0 up to 1, and np.zeros defines the n length 0 array. And when so you can now assign the value of function to variable by running over each index using like this. Okay, so yeah, you can. So here is one more function. We are using fx equals to cos x here. So now since x and y are arrays, so we can also directly assign because cos is available in NumPy, so we can directly assign cos for it. But we can't do the same thing. Okay, so in this program, it is assigning two functions consecutively. Okay, so yeah, that is what I'm telling about. So we can't use math for this so it will run because it is picking a particular entry of array x, and it is a float or integer, so it will run over it. But if you insert the whole array, it will give an error. So for that, we will use NumPy to access the cos. Okay, but still we need a math module because there are some function like factorial which are not available in NumPy, but they are available in SciPy. Okay, so suppose now we need to plot this function over 0 to 4. So first we are assigning that we discussed before the value to the variables x and y. And here we are plotting, and for plot we will use we will import the module matplotlib.pyplot and use the plot function of it to plot the graph and show function for showing the graph. So it will run like this. Okay, so you can also make your graph more readable. Okay, so like in this example, so this title for printing this title, you need this title command, and for printing this label, you need to add label as well with plot. But there is an additional command that it requires, that is plt.legend. If you remove this, then it will not print that. So it is necessary to add um, plot.legend. Okay, so you can also add labels to your x and y axis by using a plt.x label and plt.y label. Okay, so yeah, we can also plot two graph of two functions consecutively. Just we require to use plot command twice for each function, and the remaining job is same, and it will print the two curves together. And this is a precise version of the above example. Okay, so we can also plot a user specified function, and this is the journal format for using that. Next, we can also plot discontinuous and piecewise defined functions. Suppose consider the have side function. So it has discontinuity at x equals to 0. So here we are defining the function, and now we need to plot this for these values. No, not for these values of x. Okay, so if you plot it for n equals to 5, so means that we are using a very little bit points. So their jump discontinuity is not visible clearly. So we will need a nearby points. So we can take, if we will take more points, so like an n equals to 100, then it will visible that we have a jump discontinuity at 0. Okay, so we can also use a loop within the function. So like it is using in this. So and this command vectorize command will give the vectorized version of function hx that will work with an array argument. Okay, so here are some useful array operations that we need to know. So first is linspace that we discussed above, and next and second is zeros that we also discussed above. So suppose if we want to and print a to be of the size x, but containing zeros at each entry, so we can use this command for that. And we can also create a copy of x using copy command, and this will do the same job as we did here. Okay, so next is as array function, so it will convert a to an array. Okay, so we can also access particular entries of an array and can change it. So this will change the first, sixth, and seventh entry of A up for 10 to 10, and we can also use range function here to updating the values. Okay, so here are some Boolean expressions over array. So if we print a less than 0, so it will print false for positive entries and true for negative entries. And we can also access negative entries using this command. And we can also change these using this command, and a.max will compute the maximum value of array. Okay, so array can be of any dimension. Okay, so here we usually use a sparse matrix which has very less number of non-zero entries. So the more easy way to define that, first you will give A to be a zero matrix of that shape or size you need, and you can just update the entries you want to update like this. And this format and this format are the same. You can do it anyway. Okay. So any questions up to here? Okay. So do we have questions from online session? No? Okay. Okay, so next we are plotting two-dimensional functions. Okay, suppose we need to plot this function over unit square 0, 1. So we will use the mesh grid function from NumPy for that. And this will create the grid of x and y here. And we'll plot it. So plot dot grid will plot the grid of that points, and here we are defining that function which we need to plot. Here we are assigning the values that we did above for z, sorry, for y in 1D. So here we are assigning all these values to z here, and after that this plt.pclr mesh will plot the functions. So okay, so in this plot it is difficult to understand which value is where. So for that we will use a function color bar. So it will give the color bar for the function. So like in this function, 1 is at between center and 0 at the end. Okay, so now we will discuss. Okay, so I'm just giving a glimpse of triangular meshes. This we will discuss later in our summer school. So here we are plotting a triangular mesh of a unit square. Here we are assigning function to it, and here we are plotting it over the mesh. It is almost exactly the same that we did for 2D. Okay, so next is SciPy. So SciPy provides a larger number of functions that operate on NumPy arrays and are useful for different types of scientific and engineering applications. And the best way to get familiar with SciPy, you can browse this documentation whose link is given here, and you can access it obviously when it is uploaded to Google Drive folder. Okay, so last topic is dictionaries for today. Okay, so it is almost similar to the list, but here our index need not to be integer. It can be anything, any float variable, any string variable. So here we are defining a dictionary of which has index of string, like string variables. Okay, so yeah, so the index of a dictionary are known as keys. So these are the keys. Okay, so Norway, Sweden, and France are keys, and Oslo, Stockholm, and Paris are values for the corresponding key. So if you print a dictionary of Norway, so it will print a value of Norway in the dictionary. And you can also extend your dictionary by giving this value. So here you can notice that Germany equals to Berlin is entered in the list. Okay, so you can define dictionary in two ways. First, obviously using curly braces. And second way, you can define it as a build function, and you can use the DICT for that. Okay, so next is you can access both keys as well as values from dictionaries. So here it are accessing keys of the dictionaries, and you can also access value of a dictionary like this way. So it will print only the value of that dictionary. Okay, so here are some similarities between dictionaries and lists. We will discuss it here. So you like in dictionary, you can also check whether an element belongs to dictionary or not. So here it is doing, if Berlin is in temps, it will print the first one, and else it will print the second one. So what will it print? It will print no temperature data for Berlin, because obviously Berlin is not in temp. Okay, so next is, yeah, you can also check it in similar way that we are doing in a list. So you can also delete the entries from list like we sorry, from dictionary like we do in list. We can also check the length of list, sorry, length of dictionary like we do for lists. Next, you can also print the values using this command. So it will print the value of keys in the temps. Next, you can also change the value in dictionaries, and you, if you make changes in copy, it will not reflect the previous one. Okay, so here are some more example like above. Okay, so the last thing is that our dictionary is not mutable, it is immutable. So we can't change it. So for keys, we can use integers, floats, tuples, like we did in first three. One here we are using float, here we are using uh, tuple, but we can't use list because list is mutable. So if we assign list as index, so it will run an error. Okay, so this is what from my side for today. Any doubts, any queries? Okay, so any online questions? No? Okay. Thank you, everyone.
Quite a lot of stuff in. So she will share the book with you. She will also share an HTML. See if it is HTML.
Yeah, sure.
Also. Please, if you know what a notebook is and can access it, great. Otherwise, you can open the HTML file, you can copy and try running the base that have been already created. If try at your end on your have any Python. I think Python is going to get itself first, yeah, when Gaurav will fight. But over the next 2 days, they will check back. So, Archana strategy was so
Okay.
can stop this now and thank you. Okay. We have about an hour. Let's perhaps remind ourselves in our morning and continue talking. Even if not for the entire hour, let's try and do 45 minutes or something. So, okay, I'm gonna have to repeat all of that for the sake of people who are online, I suppose. So I was going to say, if you Archana will be uploading the notebook soon, please feel free to take a look at it, and we can address your Python queries over the next 2 days. Okay, and let me take some time right now, maybe 45 minutes at most. We don't want you to be like super tired at the end of the very first day. Let's try and wrap up some of the topics from this morning, and let's see how much progress more we can make. Hello. Mm. Hello. Okay, it does take a little while to warm up, I think. Hello. Since this wasn't planned, this is a little unplanned. It's going to be a tiny bit interesting to try and see how I can get this going. Hopefully, through my Zoom share, you can You can all see the screen here, I think. Okay, let's see. And folks online can also probably see my screen. And let's share.